So, our chemical reactions today are brought to you by hydrogen peroxide. All right, so hydrogen peroxide. I brought some molecules. I have these little things here. Check this out. This is so cool, right? This right here, does anybody recognize what structure this is? I'll give you a hint. You swim in it. H2O. And what we have here is we have an oxygen atom and we have two hydrogen atoms. So we have H2O. Now, hydrogen peroxide is a little bit different than H2O because it's actually H2O2. And when I say that, when I say H2, we have hydrogen atoms. We have two of them, H2O. That's water. And here we have hydrogen peroxide. H2, two hydrogens, O2, two oxygen atoms. All right? And so what we have here is this liquid. And you guys have used this at home when you have a cut or a boo-boo. Your mom or your dad or a grandparent might take some hydrogen peroxide and pour it on top of your boo-boo, and then it fizzes. You see like all these bubbles. And what's happening is the hydrogen peroxide is reacting with enzymes in your skin, and it's breaking up the goop inside. It's taking the bacteria, it's trying to knock it out, right? So it's fizzing, it's creating that fizz to help clean out the wound so that you don't get an infection. But what's interesting is if you let this sit here long enough, takes a while, a long time. Say we have these two hydrogen peroxide molecules. These two things will eventually decompose. And what that means is it means they're going to break apart and turn into something new. And over time, what happens is these things decompose into oxygen and water. So what happens is they sit here long enough, they break apart, and these molecules went from what we had to this. Now, I didn't have enough to be able to create a chemical equation to show you, but we had our original hydrogen peroxide here, and over time it breaks into H2O and then O2, which is oxygen. So what we're going to do today is we're going to speed up this reaction, because sitting here watching this is not going to be very exciting. It's going to take a long time, and you're really not going to see anything happen as those oxygen molecules break off. We just don't see it. But we're going to try to do something to capture that experience so that we can see it together. All right. So what are we going to do? We're going to try to make some elephant toothpaste. How do we do it? You need some hydrogen peroxide. Now, this is 3% proof hydrogen peroxide. You can buy 6%, and then sometimes you can get higher concentrations of 9 and 12. And then behind me, I've got 35% hydrogen peroxide, and we're going to do something with that at the end. But the first thing we're going to do is we're going to pour a little bit of hydrogen peroxide into a container. You can, if you have a little Erlenmeyer flask like I have, great. If you don't, a water bottle works well. And because this is 3%, I feel comfortable being able to handle it and touch it afterwards. Anything with higher concentration, I'm going to encourage all of you to not touch and engage with what's about to happen. Okay, you'll see what's going on. Let me move my water molecules over there, and I'll leave my oxygen right there. Whoa! All right, so what we have here is some hydrogen peroxide, and I'm going to add just a little bit of food coloring to it. So that's our first part. The second part is you're going to need some warm water. Oops. Yeah, we're going to put this in here, and then I'm going to scoop it out. Oh, it dropped. My tablespoon dropped. So what I have now is I have yeast, and this is going to be our catalyst, the thing that speeds up our reaction so that we can see it happen before our eyes. So what you're going to do is you're going to take 1 tablespoon of yeast, and I only have 1 tablespoon, but I need some water, and I need 3 tablespoons of water, but this is only half a tablespoon. So if 2 half tablespoons make 1 tablespoon, how many do I need? I'll let you do the math while I start doing it. There's a half. There's 1. There's 1.5. There's 2. There's 2.5. There's 3. So we had a total of 6 half tablespoons to make 3 whole tablespoons. And then we're going to take our yeast. Whoop, that was loud. And we're going to dump it in. And we're going to stir it up. And then we're going to let it sit just for a little bit. All right. So we're going to let that sit just for a little bit. It smells like we're about to bake something. I want to make pizza dough tomorrow. Pizza. Pizza, pizza. All right. So I also have a little bit of soap. Now you don't have to have the Mr. C brand to make this work, but it definitely helps. It's a hair-raising experience if you use the Mr. C brand. But if you use regular dish soap, perfectly fine. You're going to pour a little bit of dish soap in here. We'll talk about why afterwards. Shake it up. And because I'm not sure what size reaction we're going to get out of this, I have a bigger pan. I like to do this in a place that has a hard surface that's easily cleaned, so that if I do make a mess, I can clean it up, or if I throw it all over the place, I can clean it up. So we've got our yeast going. I've got a funnel, and I'm going to pour these 2 things in there. Hydrogen peroxide, yeast, and soap water. You guys ready? Let's try it. In 3, 2, 1. I know you weren't counting. Everybody, parents, you should be counting too. Come on. Everybody in 3, 2, 1. Here we go. Oh my gosh, it's working so well. Look at that. That is so cool. And it's warm. I can feel that it's warm. It's warm. It's creating heat energy also. So, what is happening? What is this? All right, we call it elephant toothpaste, but really, what is it? This is little foam bubbles, right? So we know if we have a bubble or foam that there's something inside of it. And there's bubbles all around it, and those bubbles are made up of a gas. Oxygen, O2. That foam is filled up with O2. That reaction happens so quickly and so fast. It didn't take a whole bunch of time to happen. The hydrogen peroxide went from being H2O2 to now being O2 and leftover water on the inside. And the soap catches the oxygen. So if we do it without the soap, maybe we try that. Maybe we do it without the soap and see what happens. Isn't that cool? What I want to also say is this. I think we should try this again, but I want to change a variable. I've just been thinking about this. What if we don't even, what if we don't put the yeast into the water? What if we just put the yeast straight into the hydrogen peroxide? I've never done this, and I'm just curious if it'll work or what it'll do. And so I think we should try that. All right, so we're going to take some hydrogen peroxide. I'm not measuring this out today. I'm just kind of adding some. All right, we're going to add this directly to it. Oh, a little bit of soap, right? I don't know what it's going to do. I'm going to add a little bit of food coloring. Got some red here. Ooh, I've got the red food coloring, and I've got the blue soap. I wonder if it's going to turn the color. It's almost, no, it's red. I thought it might turn purple on us. All right, here we go. I'm just going to do a scoop of this and just put it in. In 3, 2, 1. Oh, it's doing it a little bit. I'm going to stir it up. I'm going to mix it up a little bit, see what happens. Okay, that's cool. So it's reacting, it's just not reacting the same way. And I'm mixing it up. Ooh, it's nice and warm though. All right, cool. So we tried that. It worked. The bubbles here, some of them are ginormous. I don't know how long this reaction is going to take place. But that is so super cool. That looks awesome, isn't it? Are we getting that?
Yeah.
It's kind of gross looking because of the brown yeast. It's like all clumpy. But the reaction, I think it's pretty awesome. Thoughts? Now, we are going to do one more experiment to wrap this up today. Oh, show. All right, here we go. So what I have here, in the experiment that you're doing at home, you used 3% hydrogen peroxide, yeast, soap, and water, right? For this experiment, we're going to do it a little bit differently. These chemicals are not chemicals that you have access to. This is a much higher concentration of hydrogen peroxide. So I'm going to throw on some goggles. I only have a little bit left. This is an older container. And so my question is this still going to work? All right, because we were talking about this decomposition. The hydrogen peroxide decomposes naturally over time. It breaks the oxygen molecule off, and then it has water. All right, so we have our 35% hydrogen peroxide in here. I'm going to add some soap. I'm also going to add some, this should be yellow. I don't know if I want yellow. We'll do yellow. We haven't done it yet. I think this is yellow. Oh. It does match my coat, doesn't it?
That's not yellow, I don't think.
I'm not sure what color that was. So we're going to get something cool. What was that? Did I mix it up? Anyway, we're going to put it in here. And the reason we're putting it in here is because I don't want to get this on our tabletop. So we have our fish tank to hopefully capture all of this. And we're going to get this other camera set up so we can see it. Now this one, I intentionally didn't put an Erlenmeyer flask in here because I don't want it to shoot up and hit the ceiling and get on the ceiling and stain anything up there.
We've never done that.
We've never done that before. All right, so I have my solution, potassium iodide. It's going to be our catalyst. It's going to break down that hydrogen peroxide very rapidly. And hopefully we get a good foam out of it.
We've got a stylist saying don't do bleach at home.
Yeah, we're not going to. Yeah.
We'll listen to the experts.
Thank you, expert stylist, saying don't color Mr. C's hair. All right, here we go. You guys ready? In 3, 2, 1. Oh, that's awesome. Oh. And that's why we put it in the fish tank. Can you see the heat, though? Can you see the heat coming off of this? It is seriously warm. I mean, it's very warm. Look at it. It fogged up the glass. Can you see that? It fogged up the glass. It filled up the entire fish tank with foam. This is a 10-gallon fish tank.
Yes. Is it acid?
Is it acid? Is what acid?
I think what's happening.
No. Okay, so these bubbles are filled with oxygen. So the hydrogen peroxide is sitting in that container, the H2O2, and it's going to stay there. But when we add the potassium to it, the potassium is a catalyst. It speeds up the reaction, which causes that H2O2 to break down very rapidly. So it breaks apart that hydrogen peroxide, and it turns it into water and oxygen. So all of this foam, that's oxygen being captured in the soap bubbles. And that's what we've got. And it creates heat energy because it's an exothermic reaction. Look at that. That is so cool. Yeah, that's really awesome. Yeah, so I have a container of oxygen right here in front of me.